Hello everyone. Yes, in the last video we discussed about some rules that we have to follow when we are drawing ray diagrams, correct? Let us look at that. So we discussed about four rules. First one is if the ray is coming parallel to the principal axis, it will go to the focus. If the ray is going through the focus, it will become parallel to the principal axis. If the ray is going through the center of curvature, it will come back in the same direction. And if it is oblique to the principal axis, it will be again reflected back obliquely to the principal axis with the same angle. So these are the four rules. These rules are there so that drawing ray diagrams become easy, because every time we cannot draw normal and we cannot measure the angle of incidence and angle of refraction, and that it will become very time consuming, no? That's why by doing all those steps once, we have developed some simple rules. Then we can apply these and draw the ray diagrams. What are ray diagrams? Ray diagrams are the diagrams that we draw so that we can estimate the image position. So the object is here. Where will the image be? That we have to see. For seeing that, what we should do, I have told you before, how is the image formed? Image is formed when multiple rays of light intersect. So so now we can see, we will draw two rays of light. Wherever they intersect, we can see that's where the image is. Let us look at it in more detail when I actually show you how to draw the ray diagram for some cases. Okay.
Okay, now let us look at the ray diagram when an object is situated beyond the center of curvature. Okay, so let us place an object. Let us keep this is the center of curvature. No, so this is the center of curvature, and beyond the object is there. Let us choose an object which is very simple. That is an arrow, just a line with a head. Okay, so it's easy. We have to, in order to know where the image of this will be there, we can draw some rays of light from the top, some rays of light from the bottom, and if we know 2 points, then wherever those 2 points are going to be coming, then we can join those 2 points and make the image. Actually, what happens in real life, here there will be a light source, a bulb or something. Okay, what will happen, light rays will come like this, bounce back on reflect on touching this, and it will come to the mirror, right? And there will be several light rays coming from here, from each point on this object. The light will touch, it will come back, it will get reflected, then those light rays will come and get intersected, and at that point that particular thing we can see. For example, from here, if a light ray is coming and falling, one light ray comes like this, goes like this, another light ray comes like this, goes like this. Now wherever those light rays are going to intersect, that's where we will see this point, top point. Now this point, so wherever the light ray is coming here, it will get reflected like this against some other rays. So wherever those light rays will get intersected, at that point we will see this point. Understood, no? So similarly, for all the points wherever the light rays are going to intersect, there only we will see. So instead of drawing for all the points, we can just draw for a top point and bottom point. If we know where the top point and bottom point are, we will know all the other points because it is just a simple line. Okay, so in order to know where the intersection is, we need to draw at least two rays, no? Because two rays are supposed to be required for intersecting. One ray can't intersect with anything. So let us draw two rays from the top. Okay, first ray we have drawn. This is the first ray. Second ray, let us draw with let it be passing through the focus. Okay, two rays we have completed. Now we have to know where these two rays are going to be reflected to. How do we know that? We could either use the rules, that is the four rules that we had seen, in which case it will become easier, or we can just look at it by using laws of reflection. Laws of reflection will tell, first one is angle of incidence equal to angle of reflection. Second one is that everything is in the same plane. Here anyway we are drawing on a sheet of paper, so the second rule, while drawing we don't need it. But for the first rule, that angle of incidence equal to angle of reflection, we will use that rule and we will determine where this rays will go. First we have to draw a plane surface, that is a line, that is a tangent, a line which touches the circle at exactly one point on its circumference is called a tangent. So this line we have to draw at this point where this ray is touching. For this tangent we have to draw a line perpendicular to it. A line perpendicular to it would be, actually we should use protractor and measure 90 degrees and draw it, but now I am just doing approximately. Let us draw this. Okay, so this is the normal, it is approximately 90 degrees. Now for this, what is the angle of incidence? This is the angle of incidence, correct? No, this part is the angle of incidence, and same angle should come here. There we have to draw a reflected ray. So angle of reflection, so approximately these two are same, they are meeting at focus. Okay, so now this ray has come and reflected here. Where is this ray going to be reflected? Let us complete this ray completely. Okay, now where is this ray going to be reflected? Again we have to draw a tangent, and again normal to it. So this is the angle of incidence. Angle of reflection also has to be the same here. So actually we can see that it is not exactly same because my drawing is not good, but actually in real life it has to be same. Okay, and also you can draw it properly if you use protractor, compass and all, no? Then you will get correct exactly, but that will take too much time, so I'm not doing that. So now we have seen where the reflected rays, so wherever the reflected rays intersect, see here, this is the ray that is going here. We should not see where this reflected ray and this ray intersect. We should only see where the two reflected rays intersect. So this is incident ray. A ray which is going from the object towards the mirror is incident ray. The ray which is coming back after touching the mirror is reflected ray. So wherever two reflected rays intersect, that's where the image will be formed. Now this is the point which is reflected from this point. So the top point of the arrow will appear here. Okay, now here we will be the top. Actually if we know one point, then we obviously know where the bottom is, because if the top is here, right, the bottom has to be the bottom. We can draw one line just to see where it can where the light will come. See, if we draw a ray from here which will touch the mirror, it will go like this along the principal axis and it will touch here. Then what is the normal at this point? see here the normal is the principal axis itself, so the angle of incidence here will be 0. So angle of reflection also has to be 0, so it will come back like this. So the ray will come back like this. So we have drawn only one ray from here. That is actually enough, because we just need to know whether the whether the bottom is going to be here or here. Correct? No, we know one point. We just need to know other point. Now it has to be in one line only. If the top is here, the bottom can't be here somewhere. It has to be either here or here. Now to know where it is, here or here, we have drawn a ray of light. That ray, if it would have come here, then we would have known that the bottom is actually here. But the ray doesn't come like that. It comes back because angle of incidence is 0. So we know that the bottom is here. Now let us join these 2 points. So this is the image. What does this mean? The image of the object which is placed beyond the center of curvature will be formed between focus and center of curvature for the concave mirror, and it will be so between C and F, and it will be same size or lesser size. We can see this diminished in size, so it is diminished in size. Then also, is it erect? No, it is inverted. It is ulta. So it is inverted. Is it a real image or a virtual image? It is a real image, because it is formed by intersection of 2 actual rays. Correct? No? It is not appearing to intersect, but it is actually intersecting. So it is a real image, which means here if we place, so if we take a pencil or something here, and there is a concave mirror like a spoon, and if we place it beyond the center of curvature of the spoon, then if we place a paper at this point like this, then we should be able to see the image of the pencil. It is very difficult to try it out at home, because a spoon is also very small, and you will not know where the center of curvature is and where the focus is. To determine that, you have to do several experiments. So it's difficult to do at home, but actually in the lab, if there are equipments, you can actually see. If you keep a paper here, you can see the image of this arrow on the paper, and it is real, because you can see the image on the real world object. It's a real image. So these 4 are the properties of the image. So it is nice, no, that just by drawing the ray diagram, we have come to know so much about the image, not just where it will be, but also the size, whether it's inverted, and we also know whether it's a real image or not. Because just because it's a concave mirror, we cannot say that always it will be a real image. We will see later that virtual images also can be found in concave mirror also. Now let us look at another case. Okay, so this time let us look at the next case where object is at center of curvature. So let us draw the object again. Now let us again draw 2 rays. One ray we can do parallel again. Another ray, let us make it passing through the focus. Actually, why are we doing this? Why are we doing only parallel? First, let us look at that. Last time, in where the object was situated beyond C, we actually used the angle of incidence equal to angle of reflection rule to find out where the reflected ray will go. But based on this, we have also found 4 rules. No, if you use those rules, it will actually become much easier. What are those rules? First one is, if it is parallel to the principal, if the ray is parallel to the principal axis, then after reflection it will go through the focus. Second one is, if the ray passes through the focus, after reflection it will become parallel to the principal axis. Third one, if the ray passes through the center of curvature, then it will come back reflect back in the same direction. Fourth rule is, If a ray comes obliquely to the principal axis at an angle of incidence I, it will reflect also in the same way. So this is the fourth rule. Now first rule to exploit, we have drawn one parallel ray. Now we can do second one, because focus is here only, so we can draw a line, draw a ray which passes through the focus. But third one we can't do, because passing through C it has to be. But if we draw a ray which is passing through C, it means we have to draw it like this, and that will not touch the mirror. So that's why we cannot use the third rule in this particular situation. Fourth rule we can use, but we only need two rays. So we have done first one, second one let us do. Second one is passing through the focus. Okay, and now we have drawn two rays. So how will we know where this will get reflected? By the first rule, it has to pass through the focus. So let us make it pass through the focus. Now after this is first ray. Now we have to also look at where the second ray will go. Second ray is coming and touching here. It is passing through the focus. Where will it go? It will become parallel. Parallel. It will become parallel. It's touching here. So this will be the top. This will be the top. This will be the top of the image, and we don't have to draw again one more line for the bottom, because we know that the bottom will be here only, because whatever ray goes here it will come back. So then let us draw again one more line over. So we got the image. Where did we get the image? We got it at the center of curvature itself. So when the object is placed at the center of curvature, the image also will be at the center of curvature. Now let us talk about this image. First one, is it real or virtual? Real. Why? Because it's formed by actual intersection of lines. Second one, is it same size or different size? In this picture maybe you're not able to see exactly, but actually it will be the same size. You can see in the textbook also. Here because when we are drawing, some mistakes we will do, but you can see that in the last one, in the last one, that is this one, see the image is very smaller, much smaller than this, but here we can see it's almost the same. So same size. Third one, what it will be inverted or not? Yes, it is inverted. Where is it found? At center of curvature itself. So we have again told four things, and since we have used these rules, we need not draw the tangent, normal, and then we need not measure the angle and all, that because that will be very tedious and it will take too much time. So because now we have used these rules, ray diagram drawing becomes easy. So if it is asked in the exam, then this is how you have to draw. But as you saw that it is slightly difficult to get exactly, so I think you should practice it a little bit. Okay.
So we saw how to draw ray diagrams by looking at two cases. First one we saw was when the object is beyond the center of curvature, this one. And the second one we saw was when the object is at the center of curvature, this one. So by showing two things, I have shown you that using rules it is easier to draw. Second thing is that by the ray diagram we can determine several things about the image. Now let us look at some special cases. Here we are seeing object at infinity. What will happen? What do you mean by at infinity? It means it's a very very far object. So we can imagine maybe a sun or something, because sun is very far, no? Okay, let us imagine it is sun. if you keep a mirror and if you are taking sun rays, it will actually, do you think that there will be any ray which is coming? Wait, I'll show you. So if the sun is very far, now the sun rays are coming like this. So all the rays which are coming seem parallel actually, correct? No, we cannot say, I mean, because it is so far, whatever ray is even little bit away like this, it will go in other direction, it will not never reach the mirror, correct? No, whatever rays may reach the mirror, it will be a small fraction. So here, like sun rays will be like this. Here if we place a mirror, see, we can see that almost all the rays are parallel, correct? No, in every direction the rays are there actually, but because the mirror is very small as compared to the sun, wherever we place the mirror, so if we place it here also, see, this ray, because it's not parallel, it is not even touching the mirror. Now this ray will touch the mirror. See, now we can see that again they appear parallel only. So this is an assumption that we make, that if the object is very far away, almost all the rays that is being received from that object is going to be parallel. Okay, so here also we have just assumed that everything will be parallel. So if everything is parallel, then it will come here, it has to go through the focus. What do you mean by that? The top of the arrow is also here, bottom of the arrow is also going to be here. It means we will get a point sized image. Okay, so a very small image it will be. Okay, but actually when I showed you in the slides, here, the image is very small, correct, but it is still not point sized, no, because this is because sun is very far, but it's still not infinity, correct? Is uh, distance of 150 million kilometers. Okay, even so it is not infinity, correct? So because of that, there will be still, the image is not exactly going to be one single point, but it is a big point only. But actually if it was something at infinity, theoretically, then it will be point sized. This we saw already, with this we saw. This is also simple only. If it is between center and focus, it will be formed, actually instead of being smaller it will become bigger, but it will still be inverted and real. And this is interesting. See, if it is at focus, then the image is actually going to be never formed by intersection, because whatever rays that are going from the top are going to be parallel to each other. So what will happen, every because they are parallel, the image will be formed at infinity, so we can't really capture the image when the object is at focus. Then if it is between the focus and the pole, what will happen, it is actually not, see here, the light ray is going like this, light ray is going like this, so these two rays, they will never intersect outside the mirror, but inside the mirror if you join, they will intersect. This means that a virtual image is formed inside the mirror, and it is bigger in size, and it is not inverted, it is erect. Okay, so see, in concave mirror also a virtual image can be formed if you place it really close to the mirror. Okay, so now we have discussed these ray diagrams. Next, I think we will end this video here. In the next video we will see about the refraction. mm, Wait, we have not looked at sign convention for reflection. Okay, so when we are dealing with reflection of light by spherical mirrors, we will follow some sign, that is, wait, here, whichever is the direction of light that is towards the mirror, it is going to be positive. that is towards the right, it's going to be positive. Whatever is towards the left, we assume that it will be negative. Okay. I think I'm going to teach you about this mirror formula in the next class, and we will solve some problems. Okay, then we will look at refraction. Well, for this video, I think this is enough. Okay, thank you.